A simple electromagnet can be created by taking a common nail, 3 or 4 inch nail, and wrapping bell wire around it tightly to form a coil. In this case, I wrapped 2 layers of wire around it to increase the number of turns around the core, the metal nail. And then if I connect my 2 cells in series to that and hold it near a paper clip, we can then magnetize the nail, and if I disconnect the wires, the magnetism is lost and I can no longer attract the nail. As soon as I connect it, we can again attract the paper clips. So this is an example of an electromagnet in which we have an electric current passing through the coil and generating a magnetic field. To show that a magnetic field is generated when an electric current passes through a conductor, take your compass and place the wire directly over the compass and then connect it to the other side momentarily, and notice that the needle moves when an electric current passes through the wire. It's not a good idea to leave it on very long because it's essentially shorting the batteries out and they won't last very long. But it's good just to show the students what happens when an electric current then passes over a compass. I can also set the compass on top of the wire and notice that it rotates now in the opposite direction. Over. To increase the strength of an electromagnet, commercial electromagnets often use a copper wire which is coated with an enamel coating rather than with a plastic. It takes up less space and you can get then thousands of turns of wire in a coil. Often they'll use much finer wire as well in order then to really increase the number of turns in a coil. The electromagnet we made here has only a few turns and hence it's not a very strong one. Let's just see what happens with this one. If I connect that now to 2 dry cells in series, we then generate a current. And let me just put an iron bar in the center here. You can also just use a bolt. And when we connect that, we have then a fairly strong electromagnet. If I disconnect it, some residual magnetism is present yet. If we connect it again, notice how the paper clips are all drawn up rather quickly. You disconnect it and they drop. Connect it, and so we can generate a fairly strong magnetic field with a commercial coil such as this one. If you wish, you can buy enameled wire in an electronics parts store, or you can order from a scientific supply house, and it comes in different thicknesses, and you can use that then for making a stronger electromagnet. You want to get probably tens of meters of wire wrapped around a nail instead of only about 2 meters, as is the case with this one.